All right, so this video will focus on 10.5. And what we're going to do to start with is just kind of look here. It says that you randomly choose one marble from a bag containing 5 blue, 2 red. So let me go 5 blue. So I'm going to go 1, 2, 3, 4, and 5. I have 2 red. I have 2 green. And 1 purple. And it just says, what is the chance of finding the favorable outcome? So to choose blue marbles, that would be 1, 2, 3, 4, 5, right? There's 5 of them. It's really 5 out of 10 total, but 5 is fine. Choosing a red, there's 2 of them out of 10. For the green, there's 2 of them. For the green, or for the purple, there's 1 out of 10. For not choosing blue, that means I get rid of all the blue, and I'm left with 1, 2, 3, 4, 5 different options here. And then not choosing red, that means I get rid of everything, or I count everything but these 2. So 1, 2, 3, 4, 5, 6, 7, 8. And that's how you get the 8. These right here are not independent events. So we want to figure out the difference between dependent and independent events. Now I want you to look here, and this is basically saying that you have 3 marbles in a bag, and that there's 2 green marbles and 1 purple. And I randomly draw 1 marble from the bag, and then put the marble back into the bag for a second draw. So let's just quickly do this real fast. If I go through here, the first draw is a green. Okay. Now my options, if I want to go through here, are I could either have, because I put it back in, right? I could either have a green, or a purple. For this one, I have my green. I pull out another green. Now there's another green and a purple here. And then I have a green, and a purple. So my options between these, because I put them back in the bag, and I draw it again. So this would be like a green, green. This would be a green, green. This would be a green, purple. Then I have a green, green. Then I have a green, green. And then I have a green, purple. Then I have a purple, green, and a purple that should be purple. So purple, purple. So there's really not very many likely chances of getting the purple, purple, right? That's just not very likely. If I look here, there's a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 different outcomes. And the reason why there's 9 different outcomes is because if you think about it, for the first time I put my hand in the bag, I have a 1 in 3 chance of getting a marble, right? There's 3 marbles in there. And then if I put it back, I have another 3 chances. So I have a total of 9 chances. Now I want to show you the Punnett square just so you can see that. And if I go through here and I have my green, green, purple, and green, green, purple, this represents pulling out 2 different ones, right? And I just want to show you how to get these same numbers here. So this is green, 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 purple. And that represents these right here. Then I have my green, 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 purple. Then I have my purple, green, purple, green, purple, purple. So you can see all of these combinations, all 9 of them, same thing I did here. And it says, does the probability of getting a green marble on the second draw depend on the first? No, because I put it back in. So these are not dependent. When they are dependent is whenever I do this. It says, using the same marbles from activity 1, randomly draw 2 marbles from the bag. Well, if I draw 2 marbles, then I have limited options left, right? I mean, let's think about this for a second. If I draw on my first one, I draw a green marble. Well, then I only have 2 options left. I could either get a green, all right. Well, I could either get a green, and then I have a green or a purple. For this one here, I have a green, and then I have another green or purple option. And for the last one, I have a purple, and then I could get a green or a green. So now if I look, I only have 6 options. And the reason why is because if you think about this, for the first pull, you have 3 different marbles to pull from. But after you pull one out, you only have 2 left, right? So it would be 3 times 2, which equals a total of 6. So you have 6 outcomes in which you could pull from, right? So that's how this works. And it says, does the probability of getting a green marble in the second draw depend on the the first marble? It absolutely does in this case. Because if on the first one I have a green marble, well then I only have a 1/2 chance of getting it the second time. If I have a green marble here, I have a 1/2 chance of getting a green. If I get a purple first, I have a total chance. It's going to happen. I'm going to get a green. So these are dependent events. I don't put it back in the bag. So this is something we'll do in class where you'll actually go through and try to randomly select different marbles, and we'll see how it works and what your results are. And what you'll probably find is that you have a lot more likelihood to get like a green, and we'll have a purple in some cases, where in this one we won't have any purple. It's impossible, right? So, so that's really the beginning. Now it says here, tell whether the events are independent or dependent. So I roll a number cube twice. The first roll is a 3, and the second roll is an odd number. Well, those don't seem like they're linked at all together. It seems like I have the same. If I roll it first, I can still roll a 3 again. So these are independent. I flip a coin twice. The first flip is a heads, and the second flip is a tails. Again, these are independent. They're not dependent on each other. You randomly draw a marble from a bag containing 3 red marbles, 5 blue marbles. You keep the marble and then draw a second. Well, since I keep it, I now have, instead of having 8, I now have 7 marbles left. They are dependent on each other. You randomly draw a marble from a bag. You put the marble back and draw the second marble. Well, if this is the case, if I put it back, it's independent again. So that's really the answer to that one. All right, so the key idea here is basically that we have our independent events, which is P times A and B, which is what I did here, where I just multiplied. It's actually the first example, where I did like there's 3 chances, I then put it back and I multiply again. So in this case, is you keep on multiplying a number of outcomes that you have. What you pull one time does not affect others. That is independent. So for instance, if I look here, what's the probability of spinning the spinner in a prime and then flipping a coin tails? Well, a prime would be 2, 3, and 5. So that would be 3 out of 5 times 1 over 2. If I do this, that's a 3 in 10 chance of getting it. Because these are not dependent on each other, I could just multiply like 3/5 times 1/2. And when I do this, I get 3/10. I have a 3/10 chance of doing both of those things. It says, what is the probability of spinning a multiple of 2 and flipping a heads? Well, multiple of 2, if I look at that, I have 2, 4, so I only have 2 out of 5 times 1/2, right? These could kind of cross cancel, and I get 1/5. Or I can do 2 over 10 and get 2/10 and reduce down to 1/5. But regardless, the answer is, in this case, 1/5. Now, dependent events are different, right? Because now, if I do one thing, I hold on to it. Meaning, if I have 100 options at first, and then I do one thing, now I only have 99 options left after. So here's an example. You are randomly chosen for a game show contestants from the audience. Or I'm sorry, people are randomly chosen. So there's 100 people. You are there with 5 of your relatives and 6 other friends. What's the probability that one of your relatives is chosen first, and then one of your friends is chosen second? Well, in this case, your family members would be 5 out of 100, right? Because there's 100 people in the audience. But now, if I want to figure out your friend, that would be 6. But if one person got chosen already, instead of being 100, there's only 99 people left. So this would be 30 over 90, 9900. Now you could, of course, reduce these down. But whenever I figure this out, I do 30 divided by, let's just do this real fast. $30 divided by 9900. I'll have a 1 out of 330 chance, or about 3%. If I look at the number I just figured out a second ago, if I go back 1, 2, that's 3%, because I did 30 divided by 909 or 9,900. Just so you know what I was doing. All right, so the next one says, What is the probability that you, your relatives, and your friends are not chosen in either of the first two contestants? Okay, so check this out. This one's a little bit different. I mean, it's the same principle, but now what I'm going to do, and I want to get this calculator back in a second, but let's first do this. Now, if I think about this, there's me, my relatives, which I believe there were 5 of them, and then my 6 friends, right? So the chance that none of us are chosen would be, if I look here, that's going to be equal to 12, and 100 minus 12 equals 88. So just for the first one, right, there's an 88 out of 100 chance that we will not be chosen. Well, then I have to look down and I have to think about the second person. Now, if I think about it, instead of being 100 minus 12, because one person was chosen, it's now 99 minus 12. And that becomes 87 over 99. And I have to multiply these together. And when I do this, let's just do that. I don't know what that is offhand. So I'm going to say 88 times 87. And I get 7556, or 7656, 7656. So I'm going to write that down. 7656 divided by, and if I go back to what I was doing here, I have 100 times 99 again, right? So that's 9900. So let's just quickly divide these two numbers. And I recommend going back and looking at this if you get confused by it, because I mean, it is something new. I totally get it. So I'm going to do 7656 divided by 9900. And I get 77.3%. And that's exactly what it is here. Now, of course, they've reduced things down in the book to 58/75. I just simply divided, and I got the same answer. So it's up to you how you want to handle that. For this one here, it says, a student randomly guesses an answer for each multiple choice question. So you might know the answers to these things, but it doesn't matter. They're saying that they're just guessing. Now, how many are there for each one? How many options? Now look here, there's 1, 2, 3, 4, 5. So I have a 1 in 5 chance of getting this right. And then I have another one, 1 in 5 chance again, right? And then another one, a 1 in 5 chance. So my likelihood of just getting this test and guessing, I mean, not studying, just guessing, I multiply these and I'd have 1 over 5 times 5 times 5, which is 125. So I have a 1 in 125 chance of getting all these right if I don't study and I just guess. That's not good. Now this is a really interesting part, because check this out. You know how whenever you talk about standardized testing, and teachers always say, you know, if you're taking a standardized test, you should make sure that you can eliminate one of your options at least, right? Let me show you why that's the case. So if I go through here and it says here, imagine that we know that letter A, or choice A, for all 3 questions is not right. We're going to eliminate those. I'm now going to go through, and instead of having 5 options, I now only have 4 options, right? So I have a 1 out of 4 times 1 out of 4 times 1 out of 4. And that would be a 1 over 64 chance. Still not a great chance, but better odds than this one. Now let's pretend, because most standardized tests, you can actually eliminate 2, right? At least. There's 2, like, pretty much like, those are not it. Well, if that was the case, if there's 5 questions, and if I eliminate 2 of them, I now have a 3. So a 1 over 3, 1 over 3, 1 over 3. And if I do that, that would be 3 times 3 times 3, which is 1 over 27. Again, not great odds, but much better odds than this one, right? And then finally, if you think about most standardized tests, they don't have 5 answers. They have 4, right? So if I get 4 of them, and if I get rid of 2 of them, that means I only have 2 left. Well, that means you have a 1/2 chance of getting it right. And if I do that, I have a 1 in 8 chance. If you could eliminate 2 of the options that just seem like they don't matter. And that's why we tell you to eliminate 2. Your odds get so much better as you do this. Even if you're guessing, you have a much better chance of getting it right. So that's really your lesson for the day. And these are theoretical probabilities.